For our study area, we had 3 fed sites. So we had a tall timber filter station in northern Florida, right across the border, the Jones Center HOA, and the Albany Quilt Project. Jones Center is located in Newton, Georgia. The Albany Quilt Project is located in Albany, Georgia. That's the name. But as you can see, all fed sites were in red, and then all non-fed sites were in green. The green sites are the non-fed sites, like I said earlier. But all non-fed sites were mostly public land because we couldn't really find private plantations that did not supplemental feed. This practice is very commonly used on the private land side, so we had to look to public land to get our crops. But as you can see, they're all wildlife management areas mostly. Besides one plantation in Lumpkin, Georgia, they were generous enough to give us 1 crop, but that was on the private side of it. But as you can see, River Creek WMA, Lapwire River WMA, Chickasahatchee, and Elvedale. And generally, with our project, we were mostly inside the Red Hills region, which is, well, this area of Georgia and Florida. Lappaha and the plantation are outside of it, but we're generally looking at that historic area of the Red Hills region where quailed and managed to that nth degree. Getting to our methods, we had a goal of 30 crops to be collected from all of our study sites. All crops were collected from hunter-collected wild birds from January 23rd, 2024 to February 21st, 2025. All birds would be sexed, aged, weighed in grams, and have their date of harvest recorded. Crops would also be frozen until arriving at ABAC and be processed in a lab setting later by myself. As you can see here, I don't know if you all are familiar with the birds that Justin track, but the crop is the part of their stomach in which they just hold their food contents along with their grip, and you can extract this organ to tell what they're eating exactly because no digestion actually occurs. All digestive action will occur in the gizzard, which is also known as the ventriculus of the bird. So we can open up their crops and determine what sort of things they're eating. After arriving at ABAC, crops will be dried in an oven dryer in a lab science building. Crop contents will be categorized into 4 main categories. First being seeds, vegetative structures such as leaves or fronds, animal matter, insects, and then inorganic matter such as shot and grit, rocks. Each seed item will be identified down to species or genus, while vegetative matter or animal items will be identified to a general group, like we have ants as a group, spider, centipede. Getting to lab processing again, all food items will be individually counted. Each seed would be an individual seed, so we count each seed. And then all the groups of seeds, such as desmodium or partridge pea or grain sorghum, will be weighed as a singular group. And they'd be weighed to their thousandths of a gram. Getting to our crop analysis, we analyzed the crop data in multiple ways, but our first main method was an aggregate percentage. So what an aggregate percentage essentially tells you is on average for a crop on a property, what is the breakdown of seed consumed in that crop? It's 67% of the grain sorghum, it's 40% of the desmodium. On average, what seeds are making up that crop? So to get that number, we try to get the dry weight of the food item. So for grain sorghum, get the dry weight of grain sorghum in that crop, and then divide that by the dry weight of all the crop contents for one singular crop. Times that by 100 to get a percentage, and we have the aggregate percentage for a singular food item. This would then be averaged across all crops for a single property, thus yielding an aggregate percentage for one singular food item on a property. Then we did nutritional analysis also. We looked at strictly crude protein for our nutrition, but we looked at previously established records as far back as 1944, I believe. But we looked at crude protein, and we tried to figure out, how much protein is really in these seeds. And if we couldn't find it, we'd take the average of our found records and extrapolate that to all of our unknown crude proteins. And then getting to our statistical analysis, we ran 3 single factor ANOVAs with an alpha value of 0.05. Our first being a comparison of average species richness among sites. So on average, how many types of seeds were on site? So, 1, 2, 3, desmodium, partridge pea, and grain sorghum, or was corn present? Just your species richness in general. We looked at total crop content weights, so how heavy are the crops in grams. And we also looked at the average protein intake per crop. How much protein in grams is present in the crops? If a difference was found, a post hoc test was used. We ran 2 post hoc tests. The first being a visually significant difference test, which would tell us the difference between our study sites. So if the Jones Center had a higher species richness than the tall timbers, or if the non-fed sites had a higher species richness than tall timbers, just keeping at that property level, not going to landscape level just yet. But we also did a planned contrast to compare fed and non-fed sites. What this contrast would do was basically take all of our fed sites and acquire an average of our 3 fed sites and compare that to our non-fed sites. Basically bringing a 1-to-1 comparison to try to get that core issue of nutrition again. Looking at our items consumed, we had a total of 119 crops collected, 31 from the Jones Center, 30 from Tall Timbers, 30 from the Albany Quilt Project, and 28 from non-fed. 11 crops had no contents. These crops were then removed from the study. A total of 33 unique items were found, 24 being seeds, 5 animal parts, 2 vegetative structures, and 2 inorganic substances like shot and rocks. But as you can see here, we had the vast variety of seeds present in the crop, which is pretty usual for studies like this. But with us being in multiple properties, we would have a surplus of different seeds. Looking at our crude protein, you can see the sources on the right that we got all information from. But looking at the top, our supplemental feed, corn and grain sorghum, it's at 10.4 and 9.3%. We can see that's a much lower number than the rest of our seeds. Velospediza, beggar lice, and partridge feed also around 35%. So we can see on a seed-to-seed basis that native seed is much higher in crude protein than supplemental feed. Getting to our aggregate percentages. So looking at this chart, just to kind of break it down for you. On that left side, the y-axis, we have our aggregate percentage from 0 to 100, which is telling us, the percent of what that breakdown of that crop is. But as you can see on our fed sites, we found that a large majority, over 2/3 on all of our sites, was made of supplemental feed, being corn and grain sorghum. Wild seed did not make up a lot of the seed on our fed sites, but non-fed doesn't make sense, all wild seed present there. But when it comes to some of the seeds present, beggar lice, milkweed, and partridge pea were some of the most prominent native seeds found across all sites. Pine and privet were prominent, but not found across all sites, just due to a property basis. Then for our first ANOVA, we looked at species richness. We did not find a difference among our study sites. We all sat around about 3 species in general for our crops. But as you can see, our error bars do not overlap here. It's just strictly no difference at all. And our p-value of 0.745 is much greater than our alpha value of 0.05, thus showcasing no difference at all. Getting to our average crop weight comparison, we found a difference among the study sites, and we also found a difference among the fed and non-fed sites as a whole from our contrast. As you can see, weighted in grams to the side, but there was no overlap with the Jones Center. This was likely due to the Jones Center of the birds being harvested there much early on in the day, and the birds being harvested much early on means they didn't have much time to really eat the seed that they possibly could, and with a lighter crop, which can not weigh as much. But you'll see a comparison with that later on in protein also. But you can see here our alpha value, our p-value was much lower than 0.05, a difference for fed sites. And then also a lower p-value for our contrast result, showing a difference between fed and non-fed sites. Which coming into the study, we did believe this to be true just because, well, they're fed, they're going to have a much heavier crop because they have much easier access to seed than on a non-fed site. Then our protein comparison, like I said earlier, the Jones Center, birds were killed much easier or much earlier in the day, so they're going to have a lighter crop. And to have a lighter crop, they're not going to have as much chance to get as much protein from them. So you can see that Jones Center site is much lower. But we did not find a difference in our contrast when it comes to fed and non-fed sites. When the fed sites were averaged, there was no difference found. And looking at the p-values again, 0.004, there was a difference for the p-value for the first ANOVA result. Then on the contrast, 0.7, there was no difference found for the contrast. Getting into our discussion, our goal of educating managers regarding supplemental feed was achieved, we believed. We believe that we did get to that core issue of protein use when it comes to bobwhite. We didn't really address other issues, but when it comes to protein, we believe there's no difference on fed and non-fed sites. If bobwhite have an easily accessible source, such as grain sorghum and corn, where they can get that lower quality seed, but a higher quantity of it, they can equalize the protein from a higher quality seed, but a lower quantity of it. Our study did not address the lack of essential amino acids in supplemental feed like methionine, lysine, and cytosine. We just didn't look at this. This was very important in the breeding season, as stated earlier, but we just didn't choose to look at this. Protein is a much simpler thing to look at, so we chose to look at that. Our study also failed to look at fat or other measurable characteristics. We just chose to look at protein again. The measurable characteristics for protein are much more common in the literature, so we chose to look at protein. Other concerns such as predation, disease, and parasites regarding supplemental feed were not addressed. These are major issues when it comes to supplemental feeding for predation and disease, but we just didn't choose to look at this. This is a multifaceted issue. We wanted to focus on that one core issue of protein. And in conclusion, when it comes to supplemental feed, there appears to not be a concern when it comes to protein intake for wild birds. Future studies are required to determine the importance of other nutritional parameters such as fats and amino acids. And like with any management action, we need to research it to the nth degree in order to try to educate our land managers as much as possible. Because supplemental feeding is a very expensive practice. I mean, grain sorghum runs about $8 a bushel, and you're going to put it out, 2 bushels an acre per year. And if you put that on a property, you have to change that every 2 weeks, so it really adds up over time. And they're putting over miles of trail systems, so they have to really spend a lot of money to do this. For my acknowledgments, I'd like to thank my advisor, Dr. Jason Scott, Dr. William Moore, my professors, Dr. Walswoods and Dr. David Ray, Dwayne Elmore and Michael Hazelbaker from Tall Timbers, David Sisson from the Jones Center, Clay Sisson from the Albany Quill Project, Dallas Ingram and Brent Howes from Georgia DNR, and then multiple hunters for their willingness to give props for our study. And with that, I'll take any questions.
Do you have any questions for Michael?
So so we measure off a juvenile and adult scale with Bob White. We don't put them to days or anything, but they were different ages. Yes, different ages, different sexes. Honestly, no. So I think Stoddard and Rosine looked at this back in the, around the 50s or 60s. When it comes to sex especially, there's no difference in the items they consume. Age really doesn't matter either. They're going to consume a lot of insect matter the first 2 weeks of their life, but after that they sort of transition more to seeds. And once they're at that juvenile stage, like what we didn't have chicks at all. We just had juvenile birds, which are just, basically the same, they're just a little bit younger. Because a quail is going to live less than a year, It's that kind of 3-month span that we're kind of the distance between juvenile to adults. So there's no difference really in seed consumers. I don't think so, on the non-fed side especially. We made a flyer, put it up at different kiosks at WMAs, but with quail hunting in the state, it's a very niche thing. You gotta have a bird dog really killing quail. I think it's very hard to really get 30 crops per WMA. Hunters, they love their birds, they don't want to part with them. They'd rather not be messing with their birds at all. But most of the time, they're pretty good people. They want to help with research and help the species. But honestly, I was pretty content with what we had here. I don't think adding 2 other properties with 30 crops from non-fed would help that much.